You sure about that? HP webcam, no, that webcam. Oh, that is a horrible picture. Let's take that cover off, see if that's better. There is no way that is 1080p.
Well, they tend to say a 1080p, but then the lens, they could
lens.
have a not quality lens, or the autofocus may not be right or whatever.
The lens on it probably is horrible.
Yep. And 1080p doesn't tell you how the quality of the lens it's on it. I got that issue.
I mean, it focuses all right.
Oh, there, that was a little better. It got marked there when he was moving.
Maybe it needs a moving target. I don't know. Maybe it's well, that does not look good though.
We'll see. Point.
Dun, dun, dun.
I tell you, man, we need to ask Steve, which is more important, training the dogs or coming to the meeting? But I'm afraid he might tell us the truth.
Training the meetings. That's what's more important.
It's kind of like training dogs and coming here. I said, we could run that. They should be similar activities. We're just saying.
Auto low light correction. Maybe there's too much light.
Please wait. The meeting host will let you in soon.
If the meeting host was paying attention.
That was interesting.
Something happened. Oh. We're getting echo here.
Okay, I'm muted now. I can start the video though. You want me to stop the video too? And what's that supposed to mean? It's your own picture though. Remember that. Before you make any cracks about who's in the picture. Pay attention. Yeah, check it first.
See, in smaller view, it doesn't look so bad. Maybe it's just, I don't know. $27 for that thing.
Yeah. Oh, what do you want for 27 bucks?
Well, they had one for 19. I got the one that was slightly better,
Oh, okay.
at least according to the box.
Yeah. The reason I have this fancy dancy thing is somebody sent it to my sister. Amazon sent it to my sister and she didn't order it.
Oh.
And she said, I didn't order this. She said, keep it. You sent it through. Okay.
That was $70 at Walmart.
Wow.
For that one.
Wow.
And I said, I'm not spending $70 on a whip.
Well, you can go to eBay and find it cheaper, you know.
I $30 was pushing their limit.
I paid 58 for this, my computer. On eBay. My Chromebook.
I mean, it is actually trying to focus, so. Maybe its depth of focus is weird.
Let's just tell it like it is. They just aren't terribly impressive. The 1080p doesn't necessarily mean quality picture. Depends on the situation.
Well, I know it means it's the lens that makes a lot of difference. And I cheaped out. I bought the cheapest I could find. Well, not
These old street cam cameras. Did you want another street cam?
No.
No? Okay.
No,
These old street cams have a pretty nasty picture. up close.
It was a good picture. It is a good picture. I looked at,
This one is, yours doesn't have the black thing on the front, does it? No,
is that for voice or something?
no, that's just, it's a different model. This is the higher resolution. This-
All right, one you gave me is good, right, you know, and even in the dark, it works good.
Yeah, the 720s were pretty good,
Yeah.
and they're 720, but the lens was decent.
Yeah,
Yeah,
Yeah. Well, that's good. I just, like I said, you know, I sit there and watch my wife sleeping on the couch so much. I just don't have a use to, until we go out of town. Then it would be nice to know if somebody broke into the house or something, but really, other than that. I tried setting it up to look outside, like through the window.
No,
You can't
got to
do
turn the
that.
light out to look through the
Yeah,
window.
It was a nice reflection in the window.
Yeah, yeah.
Looking for trucks. going
They
down
do
the
have
street.
infrared things that you can mount, the infrared
Oh, yeah,
lights.
yeah,
Yeah, I got some of those. Let me know if you need one.
no. Well,
Okay.
really, if I set that up, I'm convinced that I would wanna have a Raspberry Pi server.
Yeah.
That I can leave on all the time.
This is what you
Oh,
mounted
cool.
upside. This one was outside for years.
Oh, wow,
You just put 2 screws into your sockets with this,
yeah,
and you're good.
it looks like it was outside for a while.
Yeah,
Yellow.
years. And the darn thing won't break. There he is.
Uh-oh. A super
Oh.
remote.
It's right.
started, kid.
This started.
Yeah. All right.
Yeah, the stuff is too heavy to carry in.
I don't blame you. I assume we were gonna exchange that in the parking lot. Yeah, you said 18 pounds. Yeah.
That's the receiver, the subwoofer is lighter.
Bigger, bulkier. Yeah.
Hard to get around.
Okay. Oh, good.
Were you able to find a prism by any chance? It's all right. It's all right. Don't worry about it.
I thought about it
For about 2 seconds.
3 or 4 times.
Now, I was at one of the hobby stores and I saw metallic paint pencils and I was like, I bet I could just repaint the mirror back onto that thing. Cause I bet that's all it was in the first place, was some sort of silver coating. So
I'm thinking the particles in the silver pins are bigger.
well, I figured it couldn't hurt to try it.
I'm sorry, I really thought about that about 3 or 4 times.
It's all right. Like I said, no big deal. Because this one actually works really well. So I'd have to like completely rethink what I'm doing for that small robot again to make it work. I was actually quite happy with this one. So. There's still some problems with it, but for the most part, it's pretty cool so far. I even figured out how to turn the laser off. That's it. I opened it up and went, oh, I bet if I just disconnect this wire, it'll stop doing laser thingies. Because you know what their schematic is for this? I should have gotten a picture. Their schematic is basically a block diagram that doesn't say diddly squat about anything.
Well, about a year and a half ago, I think it was, Mike Lay and
inquire if there's anybody who would be willing to help a woman install.
You want a camera? Wi-Fi camera? Street cam, 1080p,
Sounds good to me.
okay? So,
So,
it's a street cam, he's got one of my others, this is the little older,
he's retired.
technology. I'm going to a later technology.
Thank you very much.
Just look up street cam, and basically, with that model, yeah, you take it and you have a. It has a connector on it, you plug it into your router. And you load the street cam on your phone. I'm gonna show you what street cam looks like. I even show you what street cam looks like this. And you hit the add, see the plus sign, yes, add camera.
Okay.
And it'll tell you what to do, to read, scan the thing on the bottom.
QR code. Yeah, fix it right up.
Got a password built in here, printed on the.
It's 88, it's 6/8. The default password is 6/8. You probably had to reset it one time. Once you get it plugged in the first time, you gotta find the reset hole in there and you stick a paper clip through there. And you here you go, snap. And hold it down for about 20 seconds. And then it'll make a big noise.
It says reset.
Oh, okay, that's probably a thing.
Yeah, okay. The one that says reset probably is.
If you use Mac filtering on your router, you need the IP address, which isn't on there. So luckily, after hacking around a while, my router came up and said, hey, there's 2 devices here that I know the IP address on.
Yeah, what you can do is once you set it up and it'll connect to your router. Okay, you can go and look in setup and it'll tell you what the IP is.
Yeah.
That's the easy way, but if you don't know that,
Yeah, I didn't know it at first, but
I use this app.
oh, that's a good one. It scans stuff that's all around, man.
Well, whatever's on the network, it'll make a whole list
There's a
of,
bunch of ways to do it.
it'll make a whole list.
That's a good one.
Hey,
The thing about that thing, when
we
it
get
comes up with 2 IP addresses, and I didn't think about it. One's for the Wi-Fi and one's for the Ethernet.
That makes sense.
I was trying to connect with Wi-Fi.
oh,
Anyway,
you get 2 MAC addresses, right?
yeah. But I found that it works good.
Yeah.
I just,
Yeah, that one's 5-6 years old at least.
Yeah.
It's probably spent, 5 years outside hanging underneath the soffits of the house. Still got some out there, got one out back. I just got no reason to remove it.
yeah,
And the one in front that I use for the long shot of the road. You find out you have different needs for different stuff.
right.
If you have something that comes by too fast, you're not gonna get a focus on it on the close range camera. But the long range camera will catch it
Cool.
and you can see what it was, yeah. And you see me, they saw me with the trucks and they said, you got 2 pictures of everything. There's no truck in that one. One of them was the movie and one of them was a snapshot. Well, a snapshot gets the first time it sees it. And the movie will show you the frame of the last time it saw it. So as I get 2 frames, I show 2 frames. And of the 2, I'll get either the first one or the last one. So there's a lot of technique. And then if you look for a close-up, if you're looking at the close-ups and the guy's fast, and some of them are going fast,
Yeah.
then you get the long range guy, he'll capture everything. It won't be high resolution, but it'll tell you that was a cement truck.
Right. Cool.
And then you see the cement truck, and then you go to the local frame and you get the time off of it. Oh, there's the time. And then you go to the close-up, and the close-up's subject to be just a blur or whatever. And so it's an art form. It's a whole game then itself. If you're having trouble, let me know with that one, but it's
Uh,
really,
It's probably not going to be delved into for a couple of weeks, so.
okay, well, it's yours, so have
Thank you
fun.
very much.
It's-
And if for some reason I don't end up using it, I will return it.
Okay. All right, and I got a couple more. If you decide you like them, I want to play some more.
Well, I've got, my stepson gave us a couple of cameras for the front of the house. For the undering, and this would be ideal for the backyard because I don't have just a narrow band on them like that. I want to be able to look at a couple of different things.
Yeah, that'll tilt and zoom. That's pretty decent.
Well, you were talking about block diagrams. Mike Lowe asked if there was anyone about a year and a half ago that would be willing to help a woman electrify her recumbent bike. Short story, her husband had cancer and they wanted to go out and go on their recumbent bike. Hand of a recumbent bike.
Oh, yeah.
40 feet long. Well, she had acquired a number of different things from different places. But in terms of what was really there, it was a motor controller, that's one block. Battery, this is, and she was just wanting to go solder these things together and it's like a 72-volt battery. If they were to run through DIN plugs.
Yeah.
And it just fried everything that she had contact. And she wanted me to hook it up a different way, and I said,
It's done.
no, no, I'll help you do the mechanics. And put that in, which she wasn't capable of, but I'm not just soldering wires together on the hope that they are the same voltage or correct orientation, anything like that.
The block diagram for this. I'm using block diagram loosely. Let me see if I can find it. I don't think. Did I put it in here?
Flash.
Yes, I did. This is the block diagram. That is the block diagram. I use the term loosely. Everything's there, and if you read it a little bit, you'll sort of understand what's going on, but
Well, we were talking last week about, I was given iPad Pro last summer that has LiDAR and a 3D camera and doing scans.
Yeah, that's right.
But I didn't get a chance to go on through it. There is a guy on the internet who's gone out to a sculpture garden and done 6 passes around sculpture. And then there's a program that will integrate those. And then he converted that to 3D print diagram. And he said if I was just gonna leave this, I'd leave it like this, but then he cast it. It was pretty nifty.
Yeah, some people were doing like game pieces and things like that with the scan technology. Pretty cool.
He indicated that you could do a standard 3D print if you didn't have overhanging, unsupported blocks. But he ended up using 2 filament printer, with one of the filaments being dissolvable. So everything that was overhang, he built up when the ground up would be dissolvable. And when we got to something we wanted to keep, they switched over. It was pretty nifty.
that makes clean prints too, that's dissolvable. Because otherwise you're printing your stands with the same material and you gotta break it off or whatever, and then you take a little file and you file it. Or a little acetone and you go. Clean it up.
Well, this guy had also, but taken a mason jar and captured the threads around the top and screwed that, made a female that he could screw that into and printed.
I always wondered how they did that. I've seen, what the?
You turned it on. I tricked him into turning it on every time, so you can do a share. And everything. And so you can print it on that printer.
3D. Neat.
Talking about using those in the wildfires.
Really?
There's your printer. Well, just go scan your house. Upload it to this guy.
Well, I'm thinking you're only a third of the way there when you're finished printing.
That video says that it takes like 30 hours for it to print.
It's a 3,000 square foot house when it's
30, 30. Yeah, I know.
This thing
I,
took me
yeah,
8 hours.
I know.
30. That thing's fast.
It's supposed to be printing a 3,000 square foot house.
In about 30 hours. But it's not finished. I mean, they got the electrics and all that stuff.
Is it what material?
Concrete.
Concrete. The fellow across the street from us built his entire house out of concrete. I don't know how he did it. It wasn't 3D printed. They just put up forms, but the whole damn thing is concrete.
Oh, okay. That Baxter Cement near us.
Yeah, that's the way they used to
Yeah.
do it. Yeah. I saw when they were building something over on Yankee, on the lower half of Yankee. I saw them driving big concrete that was already poured down
Yeah.
that road.
Yeah.
They were just setting it up.
Haven't seen that. This guy poured it all. It's crazy.
Supposedly, well, concrete's supposed to be fire resistant and everything, so,
Well, that's true.
you know.
Well, this guy's, I don't know the guy across the street, but he may be into, tinfoil hat and tire stuff. So he may have
He's been here.
he may have a Faraday cage or something in him, for all I know, but.
I'm not into hats so much, but that underwear is pretty cool.
Better than that leather underwear the army wanted you to wear.
See what they're doing though, I mean, they're basically cross hatching it like you would any other
Yeah.
3D print.
Pretty cool. Speaking of 3D, here's my bench.
There's the boat. Oh, yeah.
Right out of the box. I didn't do any adjustments or anything. I just said trim. And the only thing that bothers me, the label on the back, like you said, isn't great. The chimney looked kind of.
Oh, yeah, it's a little,
Extruded was.
but your arch,
Yeah, I don't know.
I mean,
It was like-
that's usually where I have the
Actually,
problem.
that was the second one. The printer came, my kids got me a 3D printer for Christmas. And I just love this thing. It took me a while to figure out the setup, but it came with a little ball of white.
There's a little.
Yeah, that might have been the grandkids jumping up and down.
Yeah,
But there was a spool of white material, and I think it'd been in the box for a long
Did they come with
time.
an aluminum bat or something?
No, it's real
For the
good.
grandkids? No.
And it got halfway through and the damn wire got stuck. And so I got half a white boat. And then I opened up the good stuff and did that.
looks like. It looks like you're a little low on the front bed,
Okay,
because that should be, I think that should be more,
all deeper.
more deeper.
Okay.
More deeper,
Well, this
but
was my first real print job. I just finished that last night. And I screwed up, but it's functional. I wish I.
oh, the drain plug.
Yeah, I got a new Maverick pickup truck,
You're
just
you're
like
not-
all, they put this big old cover underneath, so if you want to change oil. The 15 Torx head screws, you gotta climb under there.
You're not afraid that the oil is going to eat through that?
No, there's no oil touching it. That's just the,
Oh,
that's the plastic or the
Just the thing.
fiberboard pan underneath
Yeah.
the rock shield.
Air dam.
Yeah, air dam. So I just cut a hole in it. And I made this thing. Yeah, this is for, well, Chrysler does the same thing. And so I made this little tool, but Chrysler has this it's part of the car, but this one didn't have it, so. And I wish I wish Steve was here with his handy tool, because I could take this off. I basically made this as the shaft.
It's
with-
upside down or
with-
something.
No, it's a shaft, and then, but it's got a hex head on it.
Yeah.
And the hex head drives this stopper. And then this guy here's a hole with a tab on it. And inside the shaft, I got two tabs sticking out this way, so you put it in a quarter turn, it kind of locks it. And you'll see a piece of blue material in there. That was a fortunate mistake. Because when I designed it originally, I wanted the plastic to be. But the shaft turned out to be so small, I thought, oh man, that's brittle, it's probably gonna break. Well, when I designed it, I was 50 thousandths too long. Perfect, I'll just put a little rubber gasket in there to take up the, so. But anyway, what I wanted to show you was, I screwed up and I'm gonna redesign this thing. I'll use it until it breaks or whatever, but. Just because you can design something in 3D doesn't mean you can make it. And when it came out, it wanted to print it this way. Or this way, and I was like. There would have been just way too much overhang and support. So I ended up flipping it and made it this way.
Mhm.
And I'm really happy with the way it turned out, except I didn't account for this ledge here. That was a right angle. And when it was all said and done, it looked beautiful, except it had these stringers that were hanging down. Yeah, I should have put a chamfer on that. And then after I got it done, I realized this is the piece I cut out from under, this is under the body. So this was the piece I cut out, and I had to, thanks to Ford, they didn't give me a flat surface, but you can see it turned out that this was a curve. So, and I didn't put the chamfer on there, so I had to hack it up and I filled it in with silicone, but the next one will have those modifications.
Oh,
He-
yeah.
He's
Not bad for my first piece.
Yeah.
You inspired me with your all your stories. And then
that's not bad.
the next one is I gotta make a hole for the oil filter. So, and you should see what they gave me to work with on that. It's got all kinds of stupid ridges and it's round and yeah, so.
We gotta
You
get
may,
them
you
on.
may just end up having the front supports.
Well, yeah. I get to experiment with some support, but no, I'm happy with the way that turned out.
On that edge or something.
The other, yeah, it was on this edge, and I made a not a skirt, what they call it, a brim.
A brim, yeah.
I put a brim around it and I lined it up with the print bed. So it went this way. So, it wasn't flopping in the breeze this way. The printer bed only goes this way. It was stable as hell. Anyway,
That is,
We gotta keep him away from who.
well, you know how many things I've designed where I didn't get quite as good of a first print. I mean, that's a great first print.
I was happy, just excited as hell.
I've gone through like. Say I needed something for some robot or something and I made something and I went, great. Except I forgot this and this.
Yeah.
Oh, wait, it printed too big or it was too small or 7 or 8 prints later and I finally get it. And then one of them I didn't even get. One of them I just finally said, the 7th one was
That's
as
good
good
enough.
as it was going to get, and I took a drill and I drilled a hole in it.
Yes. What you use for your CAD package
Tinkercad,
or Tinkercad?
yeah, it's not the greatest,
Yeah, I've seen.
but
Like I
for
said,
somebody that really
I've been
doesn't.
using that, free CAD. And I like it, but I didn't do CAD work when I was working, I'm retired now, but that's, oh, it would drive me crazy, because you design like a little section, and then you design something else that you want to cut away. And then you might put a fillet or something on, and by the time you're done, it's, oh, I want to go change that fillet. Well, sometimes if you try to change this thing, it breaks the whole model. And it's, oh,
That
to
was
throw it away, start over, it's just a pain in the ass.
That's the same with
Yeah,
AutoCAD.
so that's really the reason that why, I mean, I saw that section was too sharp, but it's not gonna be easy to go in. Chamfer it, I wish it was, but. Here's the tool,
Yeah,
you gotta use a screwdriver. I take that apart, if you got a pocket knife or something. Anybody? No, the other side, The other,
That one?
yeah.
the
There we go. Oh, yeah. Nice and tight too. That's great.
Well, it is,
Excellent.
yeah, thanks, it is, but if I can get this off, I'll show you.
work it. I
We show that to Ray, he'd go crazy, I think. That would be all it would take.
I got a little set of calipers and measured everything once. And then when I put it in as inches instead of millimeters. Oops.
There we go. Got it. Thank you. See,
Because my calipers are calibrated in millimeters and Tinkercad was set up for inches and I was like, everything looks great until I printed it.
I won't take that apart, but you can see that
Oh, yeah.
this thing's got a hex head on it. And then instead of being round, it's round, but it only goes down long enough until this little guy
You
latches with it.
You got that?
Well, I was
Just
gonna
right
say,
too.
compared to the bench, the beachy ones, this thing called, I was really afraid that this was gonna turn out crap, but it turned out beautiful. But I printed all three of these pieces on the same.
But see, this was probably printed lower. Definitely lower. than-
Definitely lower, but it's
So-
the same kind of diameter.
Yeah, but
But when I printed it, I had all three of the pieces on the table, so it to do a layer, it had to go from here to here to here back.
yeah,
But this one, once it got up to here, it was just doing this and it was too fast. I think I slowed down the feed rate to like 15 on this too.
well, there's speed is part of it, but part of it is the further off of the build plate you
Yeah,
get,
yeah.
the more there is a slight error about where,
Well, because of the table level,
yeah,
the heavy offset.
where so you could get this perfect. Because that's what I'm saying, that's what Benchy does. See, I think you're a little low
Okay.
because of this, and then it's just off just enough to make it a little wonky, just,
Yeah, I'm not sure when I printed that, if I had put the auto level on the table.
yeah, but, because that's what it looks to me like.
You can see on this one, it turned up.
It's great.
Oh, you're saying this dimension here might not be.
Yeah.
Cause
So-
that was
so
when it
the-
started.
so
Yeah,
the-
okay.
The taller it gets, the further off center it gets, or the further unlevel it gets.
Yeah.
And that's what Benchy is supposed to show you, where the
Right,
default.
right, it is a neat little part.
So, mine almost always has an arc problem, but the rest of it prints fine, so I just go, the hell with it, I don't care.
Yeah, you could spend your career, tweaking and making this better, but
But you've
I just
got,
threw
you've
it
got a perfect arch, so I would
Yeah.
kind of go, I don't care. I mean, that little extra filament right there
I was
is
thinking
really
that-
going to cause issues if you're printing very tall stuff, but printing stuff on a small scale like that,
That looked to me more like oozing, and I thought
I don't think so.
it was the extreme that needed to be tuned a little bit, though.
I don't think that's oozing. I think that's,
Okay,
because it's not as level as it could be. It probably needs to be tuned just a little
Yeah.
bit better.
Well, I think-
Your leveler itself might be off. You know, 'cause
Yeah.
you can adjust the auto leveler
right.
a millimeter or so.
Well, I need to work on that plate, and I think I'll probably make that hole a little bigger for the next version, but other than that, I'm pretty pleased with it.
I would be, if I got a benchy that looked like that, I'd be tickled.
You're the one that got me on. I would have never known what it was until you showed me. He brought his, you brought two of them.
Yeah, one was printed with film and one was printed with the SLA. Benchies are awesome. They show you defects that you don't even realize you've got.
Next project is the house.
Oh,
So you could,
They're bringing the scanner next one.
That would be cool.
Scan the house.
Yeah, I
Yeah.
saw the scanners. I thought, man, that would be nice.
your heat on your hot end might be a little off too. There's a bunch of different things that could be. I think if you look at some of my benches that are printed well,
Yeah.
they're the bottom 3D thing. It's
Same kind
deeper.
of-
It's at least another layer deep. So I'm guessing that you're off by a millimeter,
Okay. Check it out.
and it doesn't really look like it makes a whole lot of difference. So, I was waiting to kind of see if Vicente here, because Vicente always shows up after I do this.
Okay.
It's
It's a Vicente way.
the Vicente way.
Watching a YouTube video where a guy was talking about software that eliminate having to do supports. Just by, yeah. How you go around and how you let it cool. Just put a little lid on it and then move on somewhere else and they go, they're just,
That little rise that he's got, you can design those so that it auto builds supports built into it. So that it, instead of being like an overhang like that one is, it's a gradual.
But when I sliced it, I clicked it, and said, do you want supports? And at first I clicked it when it was flat. And it showed all these stringers hanging there, but it was just,
Yeah, that's because at least part of it's.
yeah, the
up
whole
off the
thing,
ground.
and I realized. I would have made it different if I
we're
were
in
there,
a different plane.
but then light bulb went off, so okay, let's make it up, stand up on end. And I didn't try to put any supports on it. But anyway, live and learn.
If there are, I've seen plenty of designs that they do it like a gradual deal. And it's one layer or two layers, and then it builds out just a little bit, and then it builds out just a little bit, and it slowly curves around. I've got a pumpkin that does it. It didn't need any supports, but it gradually builds up and around, and it's like, that was the coolest thing, because I was worried about that. I was like, oh, I'm gonna need supports, and they gotta be on the inside. No, it just.
It makes the difference, the distance too, because this one here just looks crap. But this is the same overhang up here, and it turned out beautiful.
Yeah.
So I think it's like you were saying, that if you can get enough of a start of this, because this had a little bit of support to it. So if that next layer next to the wall has just a little bit of support, I think it'll stay up. But this was just out in the air, it fell out.
That's, so this one's got the gradual arc to it, and this one
Yeah.
just is right there. It's,
So I think that software you're talking about looks for that kind
Yeah.
of stuff and
and it'll,
optimizes.
and it will fix it, or attempt to fix it. There's other ways too that, I've seen people design supports built into it, and they will put a support, but it'll miss like a millimeter, so that you could break it out easy. But it, as it's building on top of this support that's built into the design. So usually see that like in pipes or something, where if you told the software, if you told your slicer to put it, it would just fill the pipe up with supports, and you could build your own support into it by spacing them out further and making like little channels and stuff. So there's all kinds of tricks to do it. But it's,
Be nice in the slicer if you could kind of go in and say, just give me a support here on the end or something.
that is the SLA slicer program
I was
will let
using
me
the
do that.
Bluetooth.
Yeah,
They use them in here for their 3D.
the SLA will let me go in and say, I don't like this support, and I can
Oh, that-
get rid of it. Yeah, sometimes it's a good idea, and sometimes it's not. Sometimes it's better to just let it decide where the sports need to be. But the software for my flash forge won't let me do it, so it's like, okay. Anyway. Robot. Okay, so. This robot is supposed to go to space 3-3. He should be able to be oriented in any direction, even pointing at the border at this point. So I've ran into a couple of issues, but for the most part, this works. So it's telling me that my target ID is 24, which is that one right there. Eventually, I want to program this calculator to send a grid number to it, so I can tell it to
What
go
is that?
wherever.
It's not a
It's a calculator.
What is it?
Seriously.
It's a calculator.
It's gotta have some kind of.
It's a
Calculator case.
No, it's a ESP32. It's Wi-Fi. It's part of their faces
Oh, yeah.
deal. So the calculator can come off, and I can put I could put a keypad on there. I could put a joystick on there.
Oh.
It's a calculator.
Yeah.
It's not a great calculator, but it's a calculator. So, my thought is eventually, once I work out the bugs, this will be used to actually tell it where to go. So, right now I hit a button and it decides it's doing some math. It's doing some math. Driving around, is sliding, and it got off. Why did it get off? It drifted. It's all right, because it could correct itself.
Ah, good. Bingo.
And basically we'll start in any orientation.
I love those wheels, how they jigger themselves forward or back or sideways.
And
Does it know what orientation it's in once it gets in that square?
yes.
So you can tell it location and orientation.
It figures out the orientation from the April tag. The April tags give a rotation value. So I'll show you the code. There's a whole bunch of, it's not hard math, but there's some math in there. And you're basically just figuring out the angle that it's looking at. So if it's this angle, then it's facing right. If it's that angle, then it's facing left. If it's another angle, then it's facing up and down.
Well, I was thinking more along the lines of it's gonna orient itself, it's gonna find where it is on the grid. But when you tell it to go to square 24,
It's off.
are you telling it, I want you to be in square 24 facing east?
No,
Okay.
no, I could. But no, right now it's whatever it figures out would be the best.
So when it got there, was it looking at this square and knowing it was in this one or?
Correct,
Okay, because the sensor's out here.
yes.
Okay.
So the way that this works, there's more math, of
Yeah.
course. So obviously it can't read the tag that it's directly under. It has to read the tag
Yeah.
that's in front of it.
To your question.
So if it's facing, up here, that's tag 35 at 50. So it goes blah, blah, blah. Rotation is that way, so I'm facing up plus 7 would give me, I'm in grid 42, and if you look at the screen, that's pretty much what it's telling you. So if we face it at an angle, let's put it here because
What if we put it in between so it can't see? It searches until it finds one.
that's one of the bugs right now.
Uh-huh.
One of the bugs right now is, well, there's a couple. This is actually one of the bugs too, is when it's facing diagonal, it will move, but it doesn't always get on track. I think because of where my camera is, it's not always seeing the diagonal as well. But what was I lost the train of my thought. So it's facing diagonal. So right now it should rotate down and look at, it should see 30 and rotate down and see 37 and then realize that it's facing to the right. So, and it should go where it needs to go. Now, a system that actually could take account of the diagonal would have gone
Oh, sure.
right to it. But sometimes it gets off
What's the code on the back?
for nothing. For right now. See,
Name tag.
see, right now it's off because it just,
We couldn't find it.
Yeah.
Code within a certain.
Oh, we figured out something.
yeah, but once it's slightly off, it decides,
Love the motion of it. That's two
Motion.
axes,
Okay.
it'll
but
actually,
it's all driving the same.
it'll actually spin, it'll sweep. And there's another issue. I had a slightly different program. That the border is going to be a special case. Because obviously, if you want to go to 6, 0. And you're facing this direction, you'd run into the border. Or if you're facing down, you'd run into this border. Right now, that doesn't work. So none of the border will actually, it won't go to the border. But the border is a special case. Right now, it backs up. And, you know, it's still trying to get to 3-3, so it knows it's going backwards.
Now, when it reads this pattern, it reads nothing more than the ID for this location.
It's getting, gets like 5 different parameters, but it's only using the ID and the rotation values.
Okay, so if you were to set this outside of the outside border, what would it know? It would know that this is the ID
Facing the wrong way.
and that is sitting on, it would know that it was this way as opposed to this way.
And for instance, if it was facing down and it saw 202, which is the bottom border, it knows that 202 is the bottom border. But it doesn't know anything else. All it knows is that it's facing down at this point, because it could be facing down at any point. So it has to get at least one other piece of data. So it either has to turn or back up. And in my mind, I had it turning right. So if it turned right, it would turn and look at that, and then it would know, okay, now I'm facing right, and I could slide up, or I could go over and slide up.
You're saying that because all these are the same tag on the outside.
Right,
Oh, that's
right. These are all border tags.
201.
200, 203, 202.
Why did you do that?
Because when I first designed this, I thought that was a good idea.
Oh, you did this?
Yeah.
So, yeah, I noticed. Where'd you print this thing? Next door.
The when I made this first, I thought having border tags that were all the same was a good idea. I don't know if that was such a good idea.
It's just meant to be out of bounds.
Yeah.
That's really the
Yeah,
intent,
yeah, so.
to say, okay, you're out of bounds.
So if it sees that, and I want to go to 6-0 right now, it won't do it. It would see that tag and it would back up again. It would never know that it actually was.
You could fix that software.
Yeah, well, originally it was going, yeah, that's one of the bugs. Originally, it would see this tag and it would spin. So if I wanted it to go to 6-0,
Sure.
it would see this tag and go, oh, okay, I'm at 6-0.
Right.
So what I need to do, or what I think I need to do, is I need to make 2 conditions. I need to make a starting condition. So if it's facing a border at start, it just backs up. And if it faces a border when it's actually supposed to be going somewhere, then it will turn. That's what I think I need to do. So I take both ideas and combine them and go, perfect. I'm not so sure how to fix the diagonal problem now. We'll see. Now it's off. Now it's going to roll down, and it's probably going to see the border and back out. And now it's going to get confused.
So what degree of rotation does
Oh.
this encoding give it?
It's 360 degrees.
No, you can say I'm at 359. That's a lot of precision comes from this fuzzy.
It's a circle. Yeah. See, it got there, but it only got there because I gave it a little push.
You're pushing.
Yeah. But I mean, it's working. It's
Yeah,
working a whole lot better than that small.
Oh, yeah, this is significant.
So when you look down and it sees this. And you turn it off, turn it on, and it sees it again, does it give you consistent degrees?
Fairly consistent, yes.
Cause I'm thinking in terms of protractor. Yet. 1 degree accuracy on a protractor, that's a pretty damn sophisticated program. Well, protractor, and
Yeah,
I don't doubt you, but I look at this and say,
yeah. How? It's mad. It's maddening and it's magic. And now, to be honest, I'm not trying to get any type of precision. I am just giving it a range of, 180 degrees to 100 degrees. You're facing this direction or whatever the math ended up working out to be.
well, I'm
I'm not trying to give it any kind of precision.
okay. And literally, you've done a wonderful job on this. I'm not trying to second guess you in any way. I'm just thinking, at some point, you are saying, I think you need to turn this way, I think you need to turn that way. And you're giving it a level of
Don't let it fall off
accuracy.
the table if it gets that far.
You're giving it a level of accuracy that someplace or another breaks down, so that if it's 5 degrees off, it says, I don't care.
Hey.
Outsmarted.
Well, do that then, dude. I make it put it sideways. Now come this way.
Is it a female?
Well, it must
It
be.
acts like it sometimes. You got it
Ask for directions.
pointed at a
Square.
square. There you go.
Well, he's,
Have you got it?
yeah, if he gets in between the grid lines.
Yeah,
that's a problem.
and that's a bug.
He's going backward because he's at the edge. He assumes he's in legal territory when he begins.
Yeah, you guys are finding more bugs. More
Okay,
features.
There we go.
There's features happening.
There it goes. You got it.
Well, it's a hell of a lot easier to be critical than it is to be creative.
Oh, yeah.
Yeah, it's tricky
Yeah.
to read that code and go, oh,
Yeah.
I'm seeing it this way, yeah.
It's a long way from getting the code started to absolute perfection.
I don't think
Getting
it'll,
it working is here. Absolute
Yeah.
perfection is 20 miles.
Wait a
there.
minute, we have a self-driving car here, let's start.
Yeah.
that. That's what the media would say.
it almost works as well as some of the self-driving cars.
Yeah, it's done.
Long time ago. About 5 decades, I had a job looking for a professor of mathematics. My job was to test out programs that people had submitted to me. And so my job was to come up with things that would fuck up the program.
Oh, geez.
Division by zero. That was a classic.
Oh, yeah, yeah.
But it was real easy to come up with things that would screw up the program.
Yeah.
It was a hell of a lot harder for people to anticipate
Oh, yeah.
and how to fix things and recover. Okay, so I want to be clear that what I'm talking about and asking questions on are not meant to be criticisms.
No, I understand. It's,
Okay.
I'll show you a video of the first couple of these revisions that I had, and you will see just how far just how much this has actually improved.
There's a video from a guy that says, things made here, and he wanted to automate a robot to do carving of wood stumps with a chainsaw. What things can go wrong here? And do you want to be in the radius of that chainsaw?
So I used to work for Millicom. And there was a guy there that had a similar job with what she must have had. I think his name was Delbert. And the designers would design a machine, the software engineers would program the machine, and they'd get it all ready, and then they'd call Delbert.
No, yeah.
His job was to break.
Great.
It's like, what happens if I push this button? What happens if I push these two buttons at the same time? Nobody thought of that. He was the breaker.
What happens if I point it at this and do this at this time?
Well, I worked for a steel mill for the majority of my career. And basically, it was to ask those same questions. Like what happens if you have this? It's a clear answer. What happens if you have this?
Yeah.
That's a clear answer. What happens if you have this? That's a clear answer. What happens to these two and you don't have that? And it's one thing for a system to break down, it's another to kill people.
Oh, sure.
And that happened. And it's one of those things where the level of responsibility is scary.
Yes, it is. Unfortunately, I don't recall ever having anyone injured or killed by a machine design. There was a guy that got smashed in a plastic injection molding operator error, and he bypassed the safety and stuff like that. But yeah,
Well,
it's the scary thing.
you can never prevent people from doing stupid things.
Well, yeah.
But a guy had a temperature control filter there, control cab. And he was having trouble with the remote device working as it did. So he removed the window and stood outside it with a pipe thing and it's operating the controls through the windows, which means they're all backwards. And he caused the machine that's designed to handle a 16-ton piece of equipment. He turned it the wrong direction. He turned himself into a sandwich between the cab and that piece of equipment.
Wow.
Now, I never could anticipate someone doing that
Going outside of the box that they were supposed to stay in.
and take the window off. And the idea was that windows were removable so they could be easily cleaned and replaced if they're cracked and stuff. And couldn't put just a Phillips screw in there to hold them because people get screwdrivers. And so we ended up welding the windows in place. I'm sorry,
Yeah, I appreciate it, seriously.
the level of requirements to go through and do those types of things. From my experience, 5 minutes into it, you find out there's a whole bag of bugs and problems and nuts and bolts and disasters waiting. And it doesn't take much to discover this.
It's to make it bulletproof. It's a major task. And a regular programmer doesn't have a clue. Not even a clue. It takes somebody with a lot of experience.
I was gonna say something like that too. I mean, programmers generally speaking, aren't down on the floor to see the actual working conditions. They're told in a clean environment, make this thing do something.
Yeah.
And this is what we want it to do, and we can make it do it. And then we get it down on the floor and grease or oil or something gets in there and messes the whole works.
Yeah, you get a science fiction movie, you go, I want you to go from A to B. And you get it down on the floor, and it drives over 6 pieces of equipment because it's going from A to B. Did exactly what you told
Yeah.
me.
It saw the tag, it's going where I told it to go.
It was pretty remarkable.
That's the actual, for the rotation, that's the actual map. So. 180 degrees, tag rotation, 314, 3.14.
15926.
Yeah. Yeah, I carried that out to extremes,
Yeah, you get 2 significant digits.
but, if you, I carried it out to extremes and then I terminated it off. The heck with that. 70 to
Okay,
70 to 110 would be up.
that's your 40 degrees of accuracy.
Yeah,
So that's what I was kind of alluding to a while ago.
that with the little robot that I had, the little one, that seemed to work pretty well. Now, I didn't adjust any of those numbers for this. It may need to be slightly adjusted, but it's the same camera and it's looking at roughly the same area, so it should be fairly close.
Okay, now, I haven't thoroughly understood your code, but I see a 50-degree gap between 110 and 160. So there's a presumption in there.
Well,
It's going to have every one, you've got a 50-degree gap. Go up, go up, go up a little more. Okay. 70, 110, and then you got 160 to 200. So there's a difference of 50 degrees between 110 and 160. Why did I do that?
no, it's right here. Those would be the diagonals. There's your 110, 111,
Right,
and the 161.
so it knows if it's
That would be your diagonal.
between.
Angle not found within the above parameters. Figure out which way to turn the robot apart. Okay.
So see. If it's 161 to 111, it's facing towards the top and the right.
And you're getting your integer R value from reading the tag.
Yeah.
What would happen if you tightened up those intervals on the top and opened up the intervals for the diagonal?
That's what I may have to do.
Play with that.
Yeah, because like I said, this was for the smaller robot.
Yeah.
So it should be fairly close, but actually, this is the second revision of this code. And the first time I tried to mess with the angles at all.
Yeah. Oh,
So,
I'm just impressed with what
So,
you do.
I
I love it.
even when I had the small robot, I didn't mess with trying to
Yeah.
figure out the diagonal, because I was just trying to get it to work in the first
The
place.
logic looks great. So what program, what language are we looking at?
Arduino C.
Is Arduino? Yeah. Cool.
So your tag info dot rotation.
Yep.
Is the value is reading off the tag.
Yes,
Okay.
it is. I wish I had brought, I wish I had the original screenshot I had of this one. It's like a wonky number. That's why you multiply it and then you divide it to get the actual angle. It's a weird, it's like 0.743. So, I mean, it's just a weird number out there. And you get it, and it change it's good. It is, if you move the robot just slightly, one way or the other, that rotation number changes. So I'd say it,
It's 180 times the value
yeah,
over pi.
yeah.
Which is 360 times the value over 2 pi. So it looks like that rotation value is an actual number of degrees. Like,
It's
it's in degrees and then you convert it into radians.
It's staying degrees.
it's radians and you're converting it to degrees. Maybe that's
Oh,
what,
okay.
maybe that's
So
what it is.
divided by pi, yeah. Oh, okay. Pi divided by, it must be in radians.
I think it's in radians and then you convert it to degrees,
That makes
to
sense.
something that we actually think of.
Yeah, because your numbers are degrees, so that's right.
You,
Okay.
you still don't look convinced.
It's not that I'm not convinced, it's that my brain has not absorbed everything I'm reading up there and done the conversions you did when you wrote that. Okay.
That formula. Vicente gave me that formula. I probably would still be sitting there going.
Okay. Well, I'm going back to the
R probably isn't the right variable to use up there, because I'm sure it's degrees.
the nomenclature isn't the problem. The problem is me.
That's what I was,
Rotation.
uh,
wheels.
that's what I was thinking when I put R there, it's a
I
rotation.
mean, to get back to your original question, what is the resolution or precision of tag info rotation in radians? Is there a spec on that?
It, from my experience, it is really, really good. I mean, you could just barely nudge the robot and it will
Check
change it.
another degree, yeah,
Yeah. But
that's amazing. There must be like a grid or something in there, right? But it's,
no, that's just a vision camera. That's, the cameras run Python.
but he must,
Oh,
he
the-
must take
yeah.
a picture of this somehow and get that image. to
The
get
the
result.
April tags are. Does it say what those are? Yeah. Tag 36H11. That is the. That is the tag that has like a lot of numbers. I think it goes up to like 512 different individual numbers. It's an 8x8, so an 8x8 grid. I think it's an 8x8 grid.
Maybe 6 by 6, or unless you count the outside black.
You count the outside.
Yeah, that would be 8 by 8. Never heard. How is it different than the QR? Is QR just more precision?
QR is. QR contains actual information. Like you could embed URLs or phone numbers or contact information inside of the QR.
April tag is just a number.
April tags, April tags give you. There's different kinds of April tags. That vision sensor easily enough reads the 36 variation, but they give you rotations. You will see April tags like at Walmart on pillars.
Yeah.
They're floor cleaning robots. They read those tags. They know where they are inside of the building. That was one place that I got the idea to do this was watching that robot. But there was, what was the other tag called before April tags? There was another tag. Anyway, the people that licensed the other tag, changed the licensing agreement and now charge people to use it. So I think it was MIT came up with the April tags to replace it, and they opened it with the MIT license, which
nobody uses the other one.
yeah, and pretty much nobody uses the other one now. But there's April tag. It might have been Michigan State that came up with it. One of the universities came up with it because the other company turned into plot holes. But you can do all kinds of stuff with these. I mean, they're markers. Aruku was the other one. And you know, Aruku's basically did the same thing. They were a 2-dimensional item that showed 3-dimensional space.
Can you scroll down just a little bit so we can read that?
This little guy, he looks like he's just made perfectly for this
I made that now.
director set or something. Yeah, but I mean, it's, oh, unless
I made that now. It looks awesome. Yeah, it's kind of wonky.
yeah, I mean, yeah, but this guy fits perfectly.
Oh, yeah,
And then
the M5 really is big on the Lego.
yeah, cool.
So they've got Lego hose holes and there's Lego hose, and then if you took this marker off the back, there's Lego hose back there. Long time ago, before you came along, I had the little robot. I had a camera like that mounted to the little robot, and I was driving this around, and the little robot was falling on it. That's
why he's
that's what that is for. I may or may not ever do that again, but that's what. But
Really cool. This guy.
that's the laser. So
What do you use that for?
when
Why you not?
so if we had the auto navigation app on it, I could hit a button and it would just drive around, and as it got close to something, it would back up. Or so. Ow. So yeah, I turned it off, or I turned it off. I unplugged it so that
One that's the light on.
light on it.
Distance.
Yeah. So I unplugged it to save a little bit of power, we
Oh, yeah. You
don't need
know,
it.
using the-
And also so I can grab it without
Yeah.
sticking my finger in it. If you look in one of those corners, you'll see the laser, and you'll see the reflector that I think that's probably the laser, and that's probably the reflector. But that's it'll get just a distance. And it'll paint a little picture out here. And then I've got a joystick that also has, it gets the same thing, and it'll paint the map here,
Yeah,
and I can drive it around.
so that's the one you use for your lawnmower.
Could be, could be. I think that's a little
Very
small for the lawnmower. Are you? He's still reading. He's very.
Yeah, it's giving us the overall, but not the particulars about. It says you can compute the precise 3D position of the able tag, but it doesn't tell us.
Yeah, you gotta dig into it. There's a lot of stuff to it. And we don't necessarily need to know how it works, just that it works.
I understand, but I'm still fixated on, I'm looking at this tag.
And going, how does it know?
Well, how well does it know?
It's pretty good. It's pretty good. These robots that they've got. Those things are. Yay big. And they don't run into people or things. They've got LiDAR on them, and they can track each other and follow each other around.
So you said that reader is, the software for that is Python?
Mhm.
How does that interface with Arduino?
So I'm using the serial interface right now. For the ESP32.
Is it just barking out characters?
Yeah, right now. It's a JSON string. So you're familiar with Jason.
I know. I know my son programs.
Yeah.
I don't.
Jason is I think it came about with Java. And it's a way of making pairs. So you've got a bracket, you've got quotes, some information, a colon, some other information. So you look for, when you're looking at the tags, you're looking at that's not what the code is. It's code. So for instance, I am looking for tag ID CX and YX, which CX and YX.
What's these here?
And the rotation. So when I built the Python app, I actually reused somebody else's, but when they built it, they said JSON add ID number, add CX and YX and rotation, and it actually sends down a bunch more stuff, but I don't need that stuff. See, it sends down the X and Y position, the height and width, which this camera is not real good with height and width, but basically, if you're looking at it from here, this tag is going to be a certain height and width.
Right.
If you're looking at it from here,
Yeah.
so it's going to know it's, in theory, it's further away. Because it's in a fixed spot. I don't care about height and width. I could read it if I wanted to, but
Mhm.
you don't care about it. The CX and the YX, or the CX and the CY deal with, lining the robot back up. So if it's slightly off, that would be the center of X and the center of Y. So if it's slightly off, I'm not doing it yet, but it's what I'm going to have to do, especially if I'm looking at a diagonal. I'm gonna have to pull it and have it
Yeah, line itself up,
center itself back up,
yeah,
more or less,
see,
more or less.
check the rotation.
And then it's going to go off. So I've already actually got the code written to do that because I was doing that with the small robot. But this was working really well until I put the diagonals in.
Yeah.
Then it started acting funky. So now I'm gonna have to add the to get it to line back up again.
Okay, well, let me ask you this, your camera's looking down here,
Correct.
and it says, okay, I'm at rotation, whatever. And you say, I want you to go to rotation, whatever. Do you rotate about this as the center point, or do you rotate about this as the center point?
Well, that would depend on what we are trying to accomplish.
Okay. So, okay, here's what I'm thinking.
Just wanted to let you guys know, we did have somebody in here at 6:30. They found another room and they're gonna stay in there. So you guys are okay. I just wanted to give you that. So.
Okay, thanks. We've been having trouble getting it.
Turn around here.
We're getting it straightened out though. We appreciate that. Thanks. Tell them thank you. Do you know, is it the knitting club? Or?
I'm not sure what their group is.
Oh. All right, well, thanks. Thank them for.
Angry women with long needles.
That would be bad.
Yeah.
Yeah, we've been having many opportunities,
Okay,
but we're getting there.
I'm basically asking when this says I'm here, does it say I'm here based on this point, or does it say I'm here based on?
The camera.
Okay, so then if you wanted to say I'm here, but I'm in the wrong rotation, then pardon me for grabbing the wrong thing. And you wanted to rotate there, the camera would remain the center point. And you'd have to write some damn sophisticated code to get this to move along the arc of a circle and remain in the same place.
It's actually, I've already written it, but yeah. The big difference is I don't have it. So because of the angle, see, it's looking basically 90 degrees down. I'm going to have to adjust the code that I have because my little one was looking 45 degrees down.
Okay.
So this is a different. So this center is going to be different because 45 degrees, it's going to be like 45 degrees off.
Okay, but when you told it earlier, you wanted to go to this square,
Yes.
you were using this as a location, not the camera.
Well, yeah, yes and no. So it needs to go to 24. But in order to know that it's at 24, it needs to see 25 or 17 or 23 or 31.
Okay,
Depending upon which orientation it is. So if it's looking down, it needs to see 31.
I understand, but in answer to the question, I think the location is here, but it's measured from here. Okay, so if you wanted to change the orientation that would remain within the square, you wouldn't be rotating the body of the robot, you would be rotating the camera.
So, yes, if I wanted. If I needed to rotate around this. I would rotate. Yeah, it would be funky, but I would do that. So that the camera would stay on
Okay,
52.
yeah, but you're really not interested in where the camera is as
I
much as
want to know where the robot
where
is.
the robot is, and the camera is simply a way of measuring that.
And the,
Well, I say simply.
the camera, because the camera is in front of the robot. I'm taking into account that information, so. If it's facing up like it is now and it's seeing tag 37. It's going to add 7 to that ID number and know that it's on 44.
Okay.
So I care about where the robot is. I don't really care where the camera is. With the exception of needing to keep the robot more or less centered in a square. So when I'm centering the robot, I will need to know where the camera is because the camera needs to center to this. Does that make sense?
Yes, it does.
I think that makes sense.
These, what's the dimensions on each one of these?
Oh, they're good.
About.
Good
Are they
gravy.
centimeters or?
The whole block, the big block is 10.85 centimeters. The little blocks are 2.17 centimeters. I had it all measured once.
It's the only two this is the only defense I have against Steve. He doesn't have one of those. I got him.
Okay. Yeah. This doesn't do me good, because one, my calipers have both English and metric. So this isn't an even multiple. So I'm guessing that it's English units of some sort. The point I was trying to make is when this is looking down and it has an accuracy of, let's say, 5 degrees, just for instance, 5 degrees back here makes it off a long damn way. So in order to get this within the box, you've done a really remarkable job, even though you're measuring a full grid width away from the center. So the accuracy of the direction here, let's say it's 5%. Well, 5% could be
I'm not disagreeing.
any of those.
Except that, yeah. When I made it work for the small robot, I had it sitting on the grid. And I was working really, really hard to keep it, the small robot would basically fit here. The big robot takes up the grid plus a little. I mean, it's a little bit bigger. So I'm going to have to rework. I've got the basic math done, but I'm going to have to rework it to get it where instead of being, like you said, cocked a little bit, it's only got cocked like a tiny little fraction. It's going to take some work, but that's what I need to do. I mean, plus
Get pissed off at me when I ask questions. What happens if you put another sensor at 90 degrees so that you are reading here and there? Because that solves both problems.
that would solve both problems. I've got another problem with that, though. I'm out of serial ports. I guess I could put a multiplexer on there and switch ports real fast. But my other problem is how would I mount it? I'm not great at mounting stuff.
Well, you've done a fine job of mounting this.
I think like the robots that Amazon uses are using multiple cameras. I would agree with that, yeah.
But you need it though, because you do have two axes. On that rotation, so
It
it
is,
would be somewhat redundant.
Well, but the inaccuracies multiplied by the length is what's. You're wanting it to sit here.
and
And
it
it
makes,
doesn't care whether it sits here or it sits there, it's within the accuracy of your code.
Yeah.
If you wanted to have it sit here more precisely,
another sensor.
either that or you'd have to up the precision with which you deal with the data.
I think. You
Well-
could tighten up your code.
Right.
Said you were gonna try it.
Right now, it's not trying to center at all,
Right.
so. You know,
Going pretty
let me
crazy
add,
with that.
let me add some centering code in there
Yeah,
and see if I can get it to center up.
That should do it.
And
Hopefully.
Cause
I'm more of an analog guy. If it was a choice between writing code or adding another sensor,
you would add another sensor.
I add another sensor every day.
Okay, so. I'm not opposed to adding another sensor, cause it would solve a lot of weird little quirky things. But. If I'm looking at it from a cost perspective, the sensor's $50, the robot's $450.
Yeah,
I mean, you know, there's $500 worth of stuff sitting there right now, and I'm.
I want to tweak the code a little bit.
I'm just saying, I mean,
yeah, let's put this in more less technical terms. The
Money.
the robot is worth this. Leroy's brain per second is relatively cheap compared to this.
Leroy's brain is going, spent how much on this already?
Hope Patty doesn't find out.
This is not a government project, although it seems to be going that way. It's not a government
Oh,
Where this is not on the Biden budget.
this is.
I don't know, this is during an epidemic though. This is still COVID, so we could probably.
Well, I hate
Extend
to
the
go back-
emergency.
I hate to go back to my previous experiences, examples. But, I was giving a talk before a technical group, just kind of like a meetup between investment companies. And I was talking about how we were made the confined space that is 1,500 degrees, and putting a person inside that space. And the people said, well, why would you ever do that? Why would you ever risk putting a person inside that? I said, well, it's $1 million a day operation. And it takes 7 days for it to cool down. It's 7 days for it to warm up. So you're asking me to spend $14 million in the sky to go in and do 30 seconds worth of work. And the person who asked the question said, well, I guess I've never had to write the checks.
Yeah,
My question to Leroy, I've never had to write the checks.
yeah, so we understand your perspective. And then we can understand Leroy's perspective.
Yes.
He hasn't either.
Here's the small, oh, why did it stop? Here's the small one. And I'm fairly sure that it's going to get off relatively quickly. And if my hand wasn't there, it would get way off.
Oh, I see it's 45 too.
Yeah, now. I probably could have put the 45-degree mount up there. And that would have solved something, but it seemed silly to do it. See the little one. The little one flips way too much.
Yeah,
So,
Very cool,
yeah.
very cool.
Pick that thing up,
Yeah,
it's got some depth to it.
yeah, it does.
but the little one had a feature that the big one doesn't have yet. Had these tags. Turn left.
Turn left 90.
Yeah,
It was just go left.
Oh, go left. Okay, I didn't read it.
go left
Go left and turn left.
and fall off the table. So,
It just said left. Left is that way, man. It's not this way. There's right, okay.
so I had a remote, I can remote it.
Right.
That was actually Vicente's idea too. I was like, okay, that actually worked.
Very cool.
So. There's that.
And that wasn't just positional, that was instructional.
And that's all I cared about on that one too. It doesn't care if it's the rotation of the tags or anything else. It sees the tag ID and says, okay, that tag needs back up. Or
Yeah, that
go
would be
forward.
a completely different program for census as opposed to what you did. So,
Yeah.
uh,
Yeah,
you-
and I'm not planning on adapting that program to work with this.
So you would never have a reason to go left. Mounted in a positional grid.
Well, I mean, what do you mean go left?
Well, your portable tag said move
Oh.
left and turn left, but you would never have, I can't conceive of a reason why you would ever have a mixture between locational and instructional.
Oh, no.
Unless for the quarters, maybe, the
Um,
corners.
it would still, it still would go up. I mean, if it was started over there and told to go up to 0, that's gotta go left and then. But there would be no reason for me to put those tags down here and tell it to go somewhere. Cause it would just get confused because it would see all these other tags.
Is there significance to the lights? At
Um,
least there's 8 of them,
So
right?
other than my Night Rider lights on the front. The
It's not reading eight lines of code.
the lights are just fun. They cool. They were they came on the robot
Okay, gotcha.
and I figured if they're there, I might as well do something with them.
Yeah.
So that's, and then I added the Night Rider music to make it sound good. So yeah, he's scanning. But no, the lights mean nothing, and I actually thought, if it here would not be a problem with plenty of light, but if we're ever in a dark area or
Oh,
whatever,
sure,
I could turn them all white,
yeah,
make it
night light.
a night thing, yeah.
Night.
But, no, the LEDs don't mean anything. LEDs are just fun toys. You guys remember? We got 5 minutes. You remember the RCA jack thing that I got for the M5 sticks? They were just a single RCA jack that had
Yeah.
the composite video out.
Yeah.
That's a bigger one that does sound and video for that controller. Actually, it's for the white version of that controller. So I did actually try it. I did actually figure out what it does. They both do exactly the same thing. And that's it. That's the joy of it. They work. It works. It needs to be using the I2S bus on the ESP32 to drive the video. The audio just comes off of a regular pin and I think it's PWM that's just coming off of it to drive it. I thought I would share that this one was $12. The two small ones, single pin deals were what were those? $3. And yeah, nothing special about them.
It works.
I will probably. It's not what I thought it was, and it will
Yeah.
probably sit in a box.
There you go.
But it reminded me, I left in the back of my truck, I didn't bring it down, a really nice RCA bundle of cables. Yeah. I'll try to remember to get it out of the truck and bring it to you next.
Oh, okay.
I don't know where they came from.